Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and my name is Nurhanis Alia Midasan, metric number AA241048. So today we are going to present about our PBL report, Water Distribution and Waste Management System. Water distribution system ensures that clean and potable water is delivered from treatment plants to homes, businesses and industries efficiently and safely. There are some key purposes of water distribution system. First of all, the purpose is to supply safe drinking water. This will provide communities with safe and well-treated water for drinking, cooking and also hygiene. Moreover, it is for fire protection. It will supply water at sufficient pressure to hydrants in case of fires. Next, the purpose is for industrial and agricultural use. The function is to meet the water demands of industries and farms. However, the waste management system involves the collection, treatment and disposal of wastewater to protect public health and environment. It will include sewer networks, treatment plants and disposal methods to handle residential, commercial and industrial waste. The key purpose of this system is to protect public health. This will help public to prevent exposure to harmful pathogens and contaminants in wastewater. In addition, the purpose is to protect the environmental. This will prevent pollution of rivers, lakes and oceans by treating sewage before it is discharged. Next, the purpose is to prevent flooding and damage. It will help to manage stormwater and wastewater to avoid system overflows and flooding. In conclusion, these both systems are essential for maintaining sanitation, preventing waterborne diseases and also ensuring the sustainable use of water resources. In water distribution system, arithmetic sequences can be used to model how water pressure or flow rate decreases as a water travels through pipelines. In an arithmetic sequence, the difference between consecutive terms is constant. In water distribution, the initial pressure at the source can be modeled as A1. The pressure drop per unit distance is the common difference, which is D. The pressure at the various points along the pipeline can be calculated using the arithmetic model. In a waste management system, geometric sequences are useful for modeling how waste decays, multiples or accumulates over time, or how the volume of wastewater grows exponentially with population or industrial activity. In geometric sequence, each term is multiplied by a constant ratio, where R is the common ratio. In waste management, decay processes such as biological breakdown in a treatment plant follow exponential patterns while waste accumulation grows exponentially as population grows, since more people generate more waste.
So now I would like to talk about the Phyla table. This Phyla table contains facts, ideas, learning issues and actions. So first, for the facts, the water tank can hold a total of X liters of water. And the second one is water is distributed to end houses, with water decreasing by a fixed amount D for each subsequent house. Next is waste production increases over time following a geometric sequence. Next is the waste grows annually by a fixed ratio R, starting from an initial value W1. Last is the system must ensure even water distribution and efficient waste processing as population and usage grow. And next is ideas. First, use an arithmetic sequence to distribute water to houses. For the second one is ensure total distributed water doesn't exceed tank capacity X. For the third one is use a geometric sequence to model and predict the amount of waste produced over several years. Next is assess the capacity of the waste management facility to handle increasing waste levels. And last but not least, discuss possible adjustments like increasing tank capacity or reducing water usage per house to maintain efficiency. Next is learning issues. The first one is how to use arithmetic and geometric sequence to solve distribution and waste management problems. The second one is how to calculate the total sum of water distributed and verify its compliance with the tank capacity. Next is how to derive and use the formula for the total waste produced in a geometric sequence. The other one is how to compare total waste produced with facility capacity over time. And the last one is what are the implications of changing parameters like x, r, or the number of house n. And the last one is actions. First one is calculate water distribution using arithmetic sequence formula. For the second one is adjust variables like a, 1, d, and n to ensure the system remains effective. And the fourth one is calculate the yearly and total waste using geometric sequence formulas. Next is suggest improvements to tank and facility capacity based on calculated data. And the last one is propose potentially solutions like increasing facility size or optimizing system design to handle future demands. Thank you. So this is our minutes meeting.
Assalamualaikum and hi, my name is Mak Fahmi Muhammad Baizuri, matric number AA241313, and here I want to explain about the solution for part 1. For the tank capacity, we choose 12,000 litre, and for the first house that receive the water, we choose 400 litres. So to find the amount of water distributed to each house, kita gunakan formula Xn sama dengan A tambah dalam kurungan N tolak 1 darab D. Jadi first kali kita cari X yang ke-20. Jadi X20 sama dengan 400 tambah 20 darab 20 tolak 1. Jawapan dia sama dengan 780 liter. Next kita gunakan formula Sn sama dengan N per 2 darab 2A tambah N tolak 1 darab D. And then kita masukkan nilai N dia sama dengan 20. So jadi S20 sama dengan 20 per 2 darab 2 darab 400 tambah 20 tolak 1 darab 20. So jawapan dia sama dengan S20 sama dengan 11,800 liter. So which mean
Saya kepada kalian semua, nama saya Muhammad Hidayat bin Muharram, nombor matriks AA240417, ingin menyambung pembentangan tentang solution kami bahagian 2 iaitu waste management facility. Teruskan kepada soalan kedua. The waste generated by the resident increase over time. The amount of waste produced follows a geometric sequence where each year the amount of waste increase by a fixed ratio due to the population growth of the housing complex. You need to model the increase in waste and calculate how much waste the facility will need in process after a certain number of years. Seterusnya kepada solusinya. Ini facility capacity iaitu 900 kg, initial waste iaitu 150 kg, growth ratio sama dengan 1.3, number of years iaitu 6 tahun. Jadi kita mula-mula cari waste detail iaitu wajarah setiap tahun menggunakan rumus geometric sequence. Maafkan saya, menggunakan Xn sama dengan W kali R kuasa N tolak 1. Untuk tadi X1, masukkan nilai W, nilai R, nilai N. Masukkan dan semua jadi 150 kg untuk X1. X2 totalkan semua jadi 195 kg. Totalkan semua X3 totalkan semua jadi 253.5 kg. X4 totalkan semua jadi 329.55 kg. X5 totalkan semua jadi 40.128.42 kg. X6 totalkan semua jadi 556.94 kg. Yang kedua, kita perlu cari total waste over 6 years. 6 years, maafkan saya. Iaitu jumlah pembaziran pada 6 tahun itu. Jadi menggunakan rumus geometrik sequence juga. Xn sama dengan W buka kurungan R kali N tolak 1 tutup kurungan per R tolak 1. Masukkan nilai W, nilai R, nilai N. X6 totalkan semua jadi 1913.4 kg. Saja pembentangan saya daripada solution part 2. Sekian, terima kasih.
My name is Nurasha Najwa binti Syamsul Fazli and my matrix numbers is AA241255. So, my part is discussion. I will discuss about water distribution system in waste management facility. For water distribution system, as we can see from the calculation, the water distribution system was designed to ensure that all 20 houses receive an appropriate amount of water. Each house get decreasing amount of water starting 400 liters for the first house, which is A, with 20 liters less for each house after that. The water tank can hold 12,000 liters, more than enough because it's more than the calculation result, which is 11,800 liters. Because of this, no adjustment needed to this design. Next, for the waste management system, it was set up to handle 900 kg of waste. However, as the population grew, the waste pattern of rapid yearly increases. After 6 years, the waste exceeded the facility's capacity by 1,913.4 kg, highlighting a critical need to expand capacity or implement waste reduction strategies. This has made it clear that the current design wasn't prepared and adjustments are urgently needed. Thank you.
The evaluation of the water distribution and waste management systems highlighted important takeaways about their performance and future needs. The water distribution system has been a success, functioning exactly as planned. With a 12,000 liter water tank, the system efficiently supplies all 20 houses, starting with 400 liters for the first house and gradually reducing the amount for each subsequent one. This design ensures a fair and systematic distribution of water with a significant reserve left over for emergencies, seasonal changes, or potential future expansions. The system currently works well without requiring adjustment. However, there is room for improvement to make it even more efficient. For example, installing smart water meters could track water usage, detect leaks, and optimize how water is distributed. Such measures would make the system even more reliable and sustainable, ensuring it continues to meet the community's need over time. The waste management facility has faced growing challenges as the community expands. When it was first built, the facility is 900 kg capacity was sufficient, but over 6 years, the waste produced by the residents has grown dramatically, outpacing what the facility can handle. This has created a pressing problem that needs immediate attention. Expanding the facility's capacity is a necessary step to manage the increasing waste volumes. In addition, introducing recycling and composting program could help reduce the overall amount of waste that needs to be processed. The facility could be benefit from adopting advanced technologies such as waste-to-energy system, which can convert waste into renewable energy. This not only helps in managing excess waste, but also provides a useful resource for the community. These kinds of investment will ensure the waste management system is not just reactive to current problems, but proactive in preparing for future demands. In conclusion, while the water distribution system is performing effectively and has ample capacity for future needs, the waste management facility highlights the challenges of keeping up with the population growth. Immediate action is needed to expand the facility and implement waste reduction initiative, but there is also an opportunity to explore innovative solutions that will make the system more sustainable and efficient. By addressing these challenges now, the community can create systems that are well prepared for the future and capable of supporting growth in a responsible and sustainable way.